Welcome back to our very exciting webinar series. We've been on and off for the last couple of weeks, but we're back again with regular programming, and very excited to welcome you all back. For the ones that are joining us for the first time, welcome to our webinar series. You can check out our previous sessions on our YouTube channel. You just need to search for the FirstUniv account, and you can find all our previous sessions there. So, we've been getting some incredible feedback, and we're always trying to come up with new, interesting, practical topics that can give our future learners the clarity that they need before pursuing their careers in the world of artificial intelligence and machine learning. And today we are going to speak about deep learning, another very interesting component of the overall AI ecosystem. It is something that powers a lot of our automations like self-driving cars, autonomous planes. And Dr. Kushal would be very happy to talk more about the practical applications of the deep learning program. And my name is Dipit Sharma. I'm the Director for Alliances and Partnerships at FirstUniv and your moderator for today's session. As always, please use the chat box to ask as many questions. We are here to learn, and often we notice that it's just the questions that you guys ask. We sort of go on a new path and discover new things. So please keep it as organic and as communicative as possible. And we welcome back Dr. Kushal. Dr. Kushal is, of course, a PhD from Punjab University in Chandigarh, qualified for GATE and UGC NET. He has been teaching for many years now and has helped countless students achieve their ambitions through his teaching and guidance. He's also an active researcher. He's published a lot of books on AI and complex systems. So we welcome back, Dr. My bad, sorry. Sorry about that. So welcome back, Dr. Kushal. And again, we are very happy to have you as always. So over to you.
Okay, thank you, Dipit. Thank you for the nice introduction. So today we are going to talk about deep learning. And first I will go through its historical origin, how it originated, that basic learning originated and how it converted into deep learning. After that, I will talk about what is state of the art, what people are doing, and how you can keep yourself updated. I will share some link of very popular and hot conferences with you. And from there, the sources to know what is happening right now in the field of deep learning. So let us begin. And so let us talk about brief history first, and after that we will go ahead. So what happened in 1987? So there was a very good researcher, Geoffrey Hinton. So he's termed as father of deep learning. Okay, so because when everybody was thinking that the perceptron cannot be trained, so he showed how it can be done. Okay, so it took him like 15 years to do these things. He and his research group, students and his postdoc fellows, etc. So in 1987, we have the idea of neural networks, artificial neural networks, and propagation. And in past 30 years, if we see what has happened after the 90s, the computers has gone really fast. Today, we have very good processing power available with you. We have the concept of GPU, tensor processing unit, and multi-processing environment we have, very good environment. And these are very accessible also, if you see like Google Colab or Amazon Web Services. Okay, and we have data available with us, huge amount of data, and the data with very different kind of modalities. Okay, and what has happened? The deep learning has seen very fast progress. It was incepted in 2014, but after that, 2017 onward, if we see the number of papers published on deep learning are huge, very large number, and you will see these terms very frequently like backpropagation, neural networks, transformers, GANs, attention mechanism, visual attention mechanism, which is a recent concept, just 1 or 2 year old. So this is what is happening in the history. Okay, and along with it, we are enabled by the software tools. We have very good libraries like TensorFlow, Keras, PyTorch we have. Okay, so the Keras is actually inside TensorFlow. So and we have Keras and many other packages available with us. Okay, so what happened with the neural network? That initially that there was the thought that the Rosenblatt incepted the idea of perceptron. Okay, and he published the paper. Actually, he mimicked the biological neuron. Actually, what is it? In 1962. Okay, and he popularized the idea that it can learn anything. Okay, but there was some debate that whether it can do it or can't do it. So there was like that if you give it two set of objects, it can become a discriminator. It can, if you further show it something which it hasn't seen, it is going to classify it correctly. Okay, then what happened is there was some researcher, they were skeptical about it. They said that it cannot do very useful computation. Okay, so there was a lot of debate about this. Okay, and once there was something which is called as AI winter, AI first winter, AI second winter. So what happened that in machine learning, the progress actually stalled because there was some paper published that it is not a very promising architecture. Like neural networks are not very promising architecture. But suddenly something happened that some very good researchers like Hinter, Rumart, and Williamson, they showed that with the help of backpropagation, you actually train the networks. Okay, so that was the groundbreaking thing. And let me tell you one thing: when we talk about artificial intelligence, there are two major branches we can think of, like symbolic AI and connectionist AI. Whenever we say symbolic AI, so we talk about the rule-based system, symbolic manipulation and stuff. But when we say connectionist AI, that it means that we are dealing with the neural networks. Okay, and so what happened between 1990 and 2005? So we have these very statistical approaches were very much popular. Okay, that you have to design your own feature and you have to like choose the classifiers and stuff. Okay, so feature engineering was one of the like central rule was there. Okay, so that if you say Bayesian approach is a statistical approach, then there was support vector machine, which is a very popular architecture. It is even used today when you have higher dimensional data. So it is very useful for that data. If you want to build a classifier on a high dimensional data, it has only one weakness, that it trains slow. Otherwise, it is a very good machine learning architecture. Okay, and neural nets got banished from it. I told you why, because there was some research work published that neural nets cannot be trained perfectly, and they are not going to converge very well. Then what happened between 2005 and 12? That neural networks were resurrected. People showed that actually it can work. Okay, so that was the time when it was resurrected. Okay, so it was the era where people fought this AI winter. And after 2014, if you see the number of papers published in the area of deep learning, you will find a huge number of papers published with the help of neural networks, be it classification, prediction, and you go for the stocks, and you name anything, how to handle co-purchase data and stuff, anything, how to handle earthquake data even. So all those areas, their neural networks were explored for all those areas for prediction. Okay, and now what is the current state of art? So why deep learning became popular or machine learning became popular? Because we have lots of training data available with us, and we have very good, powerful computers with us. And there was some improvements in training algorithms, and there were some problems like exploding gradient, vanishing gradients. Okay, so people solve those problems actually. So there are three things that we need. We needed data, we had it. We need computation power, we had it now. And there was some problems with fundamental techniques. Okay, so people improved on those techniques. So we have all conducive environment with us. So what will happen? So the field is going to explode. So people are going to come, they are going to take the models, they are going to apply it to their data, and the field is going to show a lot of promise. So that is what is happening right now. Okay, so before going further, that we all know that the all idea of deep learning, which is based on neural networks, artificial neural network, it is coming from where? It is basically we are modeling the neurons of human brain. Okay, so if you see how the neurons, like a very large number, like 10 raised to 10 to 10 raised to 11 number, and the brain works in a very distributed manner. There is no central control, and the brain works in the order of millisecond. Okay, 1/1000 second. But and it is very fault tolerant also. Okay, and it works on majority voting kind of thing. Okay, and as we will go to any AI textbook, any good AI textbook, you will find discussion for all these things there. And the reason for that is that you will not be able to appreciate the things we have leveraged with the help of deep learning by mimicking the human brain. And you will also understand where the artificial neurons are lacking. Like human brain is very fault tolerant, whereas the artificial neural network we simulate on the chip or we hardwire them on the chip, they are not fault tolerant actually relative to the human brain. Okay, we are not able to achieve that level yet. Okay, so we know that what we have in computational this conventional computer, we have one very smart, not one very smart CPU, but very fast CPU, and we have like some peripherals around it. They do the distributive processing, but in brain we don't have any central control, and the cell itself in human brain, it is very smart. It knows how to take the inputs, how to combine that, and how to fire, how much charge to fire from the axon, and how to activate other neurons. So the human brain, the cells in human brain, the biological neuron, they are altogether different from this artificial neuron. Artificial neurons are mimicking some of the portion of the human brain. And what is happening that there are many neurobiologists. They are studying neurons to more detail, and many computer scientists are working with them closely to mimic more features, to make the artificial neuron more versatile, more adapting, more close to the human brain. But this is a very long path. So currently, we can say if we rate, if we want to achieve our progress to 100, like we are on like 1 or 2. We just started. The humanity is very like into their infancy about mimicking the artificial neuron. We are very in the infancy of that process. Okay, so if you see this slide in the top, so this is how a biological neuron will look like conceptually, that it is going to have some incoming connection. Then there in the center, sorry, so in the center there is going to be cell body, and it is going to process all the inputs, and it is going to the long dark line. This long dark line is actually it is called as axon. It is going to fire the charge, and in the end it is going to activate other neurons which are going to follow this neuron, and same likewise it may be receiving some input from the other neurons. So what we have done is what the computer scientist has done. They have mimicked it in the following way. Like you can see the diagram below. So it will say it is going to take input x1, x2, x3, xn. It is going to be the signal. Actually, it is receiving from the previous artificial neuron as biological neuron is receiving. So each signal don't have equal importance. So importance is decided with the help of weight. So these the weights W1, W3, W4, and there is some bias, and they are combined. And after combination, we are going to use some transfer function, which we also call activation function, and then we are going to produce some output y. And the whole war in the machine learning is where we want to learn the appropriate weights. If you have a neuron, artificial neuron, and you know what appropriate weights I have to set, like these WIs, then you have won the game. That you have trained your neural network well. So everything what we are doing in this deep learning or with the artificial neurons, that we want to find these appropriate weights. Okay, so what see what is happening, that net is going to be what? It is going to take the weighted sum of your signals, and it is going to add some bias, and then a function is going to be applied on them. Okay, so this function can be linear function, it can be thresholding function, it can be sigmoid, it can be tangent hyperbolic, or many functions are there. There are large number of research paper on that. What activation function you should use, like ReLU, leaky ReLU, many functions are there. Okay, and it all depends on application, that where you should use what. Okay, so this is a simple example. So there is a concept in computer science which is known as functional completeness. So functional completeness says if your computational architecture perform and, or, and, not operation, okay, then it becomes functionally complete. It means what? That your computational model will be able to compute everything which is possible to compute. Let me reiterate it. Neural networks are proved to be functionally complete, which means that it can mimic AND gate, it can mimic OR gate, and it can mimic NOT gate. So there is theory in computer science that if you can mimic this thing, if you can mimic these things, these three gates, then you can compute everything which is possible to compute. Okay. So let us see first that this is the truth table on the screen for your AND gate, and you can say that you can give it 4 inputs, and corresponding it is going to produce 1 output. So there on the right of my screen, there is a small neural net is built here. So this is going to take two inputs, x1 and x2, and it is going to take the weights one each, one weight is given, and bias is kept as -1. So other weights can work here. So other weights, other combination can be found here. And if you see anything, if you put these inputs, like you set it 0 0, so it will output you 0, because it is going to combine the sum, and if your sum is greater than 0, then it is going to fire. Okay, so with you can easily check that this is something, this is mimicking the functionality of AND gate. Similarly, you can see the functionality of XOR gate can be mimicked. Okay, and similarly, you can see the functionality of NOT gate can be mimicked. Okay, these are not difficult to build. Okay, and there is a special case with XOR gate, why this XOR gate is on this slide, that with single neuron you cannot create XOR gate. Okay, you need at least 2 layers in tandem. Okay, so that was it was written here. What it does, it shows that for solving complex problems, you cannot solve it with the help of single neuron or single neurons in one layer. You need to have multiple layers. Okay, so before going further, that we talked about deep learning. So this is the person, Geoffrey Hinton. He is very central figure, and he showed to people that actually neural networks can be trained. Another guy, Jan LeCun, he solved exploding gradient and vanishing gradient problem, and he is the inceptor of convolutional neural network, very popular neural network architecture for doing image processing. So, so possibly, hopefully, if you are using some camera on your phone or something, some application, so the architecture is there. It is using neural network, because convolutional neural network is very popular and very useful also. Okay, so let us talk about deep learning. So what is deep learning actually? It is a branch, it is a subset of representation learning, which is a subset of machine learning. Machine learning is a subset of artificial intelligence. Whenever we talk about deep learning, so we are exclusively dealing with the neural networks with two or more layers. Okay, so there is going to be hidden layer. Let me show you the architecture. So suppose you have input layer and you have an output layer. In between, you are going to have the layer in between them are called as hidden layer. So the neural network, which have like 3, 4 or above higher layers, they are very useful. For example, there is a program, its name is Alvin, very old written program. So it learns driving. Okay, so if you drive it and if you plug it to the car, to the appropriate sensors, it is going to learn how to drive, when to take a run, when to take a turn, when to take left, when to take right, when to do brake, when to slow down. It will learn. Okay, so so deep learning is nothing, but it is a sub branch of this machine learning, where we deal with the deep neural networks. What is a deep neural network? Where we have input layer, output layer, but inside those layers we have many hidden layers. Okay, 2, 3, 4 or higher number. Like for some neural network, we have more than 100 neural these hidden layers. Okay, and we already discussed why the deep learning is becoming popular at this time, because we have all important things available with us. We have huge number, we have large number of data with us. We have very good computing power, as well as we have some very good methods to train neural network and to solve the problems like exploding gradient and diminishing gradient. And the key point why deep learning is becoming very popular, if you talk to any researcher, the thing is automatic feature extraction. We don't have to do feature engineering. Okay, so that thing, there is a trade-off between feature engineering and this computation power. So what has happened, that initially the work which researchers were doing, that designing feature, that has been left to these deep neural network, initial layers of deep neural networks. Okay, so there is going to be more layers, but they are going to extract feature automatically. Sometimes those features are not human understandable, so that's why there is a quest for explainable AI, that you have these weights on the neural network, explain the meaning of those weights, why these weights are there, what they signify. Okay, and if you see the progress of deep learning compared with the traditional algorithms of machine learning, so as we are gathering amount of data, large amount of data, so if you try it on the one on machine learning algorithm, traditional machine learning algorithm, like these trees and some other techniques like boosting, bagging, or some regression techniques, and if you do same thing with the help of deep neural network, if you have large amount of data, so deep learning architectures or deep neural nets are outperforming these algorithms on an average. So that's why people are turning to the deep learning. This is the reason to turn to the deep learning. And there are, at present, if you talk about what are the popular deep learning architectures, so CNN and its variants, there are like VGG, LXNet, single shot detector, all these are based on convolutional neural network. Similarly, in 2019, there was a great discovery, its name is Transformer. So this is the most successful model to apply for natural language processing. So it used some mechanism which is known as attention mechanism. Okay, so that attention mechanism is like we know what neural network is doing. So this model is efficient, as well as there are things that we can explain what is this neural network is doing. And another thing that we have heard about a popular neural network, that its name is GAN, the generative adversarial network. It has two pair of networks there. One is going to behave as generator. Another is going to behave as discriminator. Okay, so they are training in adversarial manner. Okay, and with the help of GAN, there are many applications like deep fake fake is one of its applications. Recently, there is a paper that to solve minority class classification problem, a person has developed a GAN which is going to produce you the sample from minority class. So the most of the work today is like in this direction. Okay, so deep learning architectures are very popular, and there is only one issue with the deep learning architecture. Your system should be able to handle a large amount of data, as well as it is going to take very great computational power to train these networks. So what is happening? What is the trend right now? That large organizations are going to train the architecture, and they are going to release it. And the other researchers, they are going to take those architectures, and they are going to gather their data, small data, and they are going to retrain some of the portions of that bigger architecture. They are going to add some layers to that, and they're going to train those architecture with the help of their data, which is known as, this thing is known as transfer learning. So this transfer learning is becoming very popular. You will find many papers with transfer learning, that application oriented paper with the transfer learning. Okay, so if you are planning to study artificial intelligence, and especially machine learning and deep learning, so it is highly likely that you are going to see these terms: transfer learning, GAN, transformers, and CNNs. So the basic, if you understand their some of the fundamentals, you will be able to track what is state of the art, how it is happening. And if we talk about like few important conferences where the latest AI research is published, especially machine learning and deep learning, so you should follow these three conferences: this computer vision and pattern recognition, CVPR. Okay, follow their papers. The most of the groundbreaking research is published there. And then we have this triple AI. Okay, and then we have neural lips. Initially, it was about NIPS. So neural information processing system. So please follow these sources. You will see that what latest work people have done. Okay, so this is it from my side for the basic introduction of what is deep learning, machine learning, what is this transfer learning and deep learning, why it is popular, what people are doing right now, what architecture are popular. And one more thing I want to add before the opening up for the discussion, that attention mechanism is also being used in like vision now. Okay, so attention mechanism has become very popular. So if you take up any paper, you will see these terms there: attention mechanism, visual attention, and the attention for the text. Even this, people have tried this for speech also. Okay, so I want to stop here, and I will take questions, whatever question you want. And I want anybody who is a fresher in this field, please follow these conferences. Look at their papers. You will understand what people are doing right now, the top scientists. Over to you, Deepith.
Right. Thank you, Dr. Kushal. That was very, very informative. And, I think today we were able to do a real deep dive and not only talk about, the buzzwords, but I think, an excellent job taking us through the entire process and the foundation and the mechanics of deep learning. And, I also personally feel that, there's a lot of potential in deep learning, and I think it's a very fascinating facet of the overall AI umbrella, and I hope our students also feel the same. And of course, when you do sign up for the course, there'll be a lot more interactive sessions like this, and of course, Dr. Kushal would also be involved, and we'll also do a lot of practicals and give you some situations where you are, we make you think, and you come up with the solutions yourself. So it's a very holistic sort of way of teaching that we are going to go with. And In addition to that, our team is of course here to help you with any doubts or questions. And often, after the session also that we do hear from some of you, and we have forwarded those queries to our panelists, including Dr. Kushal. And we just want to make sure that you have everything that you need in order to be successful down this career path. And as our team must have mentioned, we also feel that we will be giving you some certificates of attendance. So if you are interested in that, so I think in the chat box, someone from our team would be writing down the contact address, so you can contact us for the certificates. And also, it's a first year guarantee that when you do sign up for the course, we will make sure that you get placed, and you get a couple of interviews. And at this point, if there are any questions, if there are any doubts in regards to, okay, I think we got a question already. It's from Aishi. I'm a
Okay,
BCom
so
student. Yeah.
So Ayush is saying, I am a BCom student. Will it be hard for me to learn the course? So see, Ayushi, there is one thing which I want to mention you clearly. That you need to have some aptitude for programming and understanding of basic maths, so 12th level maths. Okay, so you should be able to know what is differentiation, what is integration, what is slope, what is the derivative, okay, what is the partial derivative. Okay, and you should have a aptitude for learning Python. Python is very easy language. Its learning curve is very easy. So if you are open to learn it, then we can teach it to you. But the thing is that you need to work with the mathematics, like some probability theory, some linear algebra, and some like calculus. And along with it, some programming in Python. Okay, so if you are ready to do it, you are ready to put in, like, you are ready to burn your midnight oil. So it will be easy for you. Okay, you will be able to do it.
Right. Thank you, Dr. Kushal. And so this is one question that we get in almost every session. We've had people asking from the healthcare sector, from the travel and tourism sector. And I think this is okay. Before I answer that, I think Rahul has another question for you, Dr. Kushal.
Okay.
Okay. Yeah.
So Rahul is asking, deep learning, is it full-time work or part-time work? Rahul, right now, what is the state of art that majority of the researcher are using deep learning because we are having a huge amount of data. So it is not like in research, nothing is like part-time or full-time. If a particular algorithm or aspect shows the promise, people switch to that motion. And if it doesn't show promise, they try something new or they improvise it. Okay, so that is the thing. And can you elaborate more about future of deep learning? See, Nawab, what is happening that you already know that we are having progress in VLSI technology, that we are able to build fast processor and that of low cost. So we are having abundance of computing power, and with the advent of social media and internet 2.0, we have huge amount of data gathered with us. Okay, so and we have very good algorithms with us. So what is happening that we have all conducive environment which is required for deep learning. So people are trying different architecture. They're proposing new things, like fairness of AI is there, and like the explainability of AI there. Many different kinds of streams are coming up. So the future of deep learning is very bright. Okay, because when you have huge amount of data, human cannot make it sense by looking at it. You need a machine to do so. Okay, and in deep learning in particular, when you have unstructured data, so the unsupervised learning and reinforcement learning, they're going to be like hot fields in the future. They are hot fields, and there is going to be more progress in that. Okay, so, and please do follow the links I showed you in the PPT, that like CVPR, AAIN, and Neural Labs. Please track these conferences. There is a magazine, its name is Medium Digest, online magazine. Reads article. It will keep you updated and posted that what is happening there. Okay, what are the most used applications for deep learning? Say, Sudhanshu is asking. So, like, if you want to do image classification, image recognition, you want to do the prediction of some kind of, like, for example, you have data of earthquake. You want to see when next earthquake is going to be there and how much intensity. You can do it with the help of deep learning. So, Amazon has huge amount of data. So they you see the recommendation there, like the users who purchase this product, they have also purchased this product. So that is happening with the help of deep learning. Okay, and like many optimizations and other stuff, numerous applications. Okay, like image processing. Right now we are talking, so there is background noise. There are some softwares which are going to remove the background noise. They also work on the technique of this machine learning. They have some architecture for blind signal separation. They are separating the background noise, and they are like upsampling or the strengthening the foreground signal, which is our voice. Okay. So these are applications of deep learning. And another, how FirstUniv course is different from other platform which is offering the same course. So see, there is a difference with this course that we are offering you the mentorship. On the weekends, we are going to talk to you people. We are going to have the sessions in the group. If we are facing any doubts, queries, we are going to solve those queries. Okay. See, this thing is called as personalization. So that is different from this course. If you go to the Coursera, you can take the course, but you cannot go for the doubt clearing session. Okay. And you know that everybody has different learning curve, different aptitude. So if you and the people have different doubts. For example, somebody is weak in math, so he may need more footing on this mathematics. Somebody is good in math, he's from math background, but it is poor in programming, so he needs more footing on the programming. So that's what our team is going to do for you. And Anu is asking, sir, what is logistic regression? So this is a supervised learning algorithm which is used for prediction. Okay. So logistic function, you know, if you are from maths, logistic function, that function is used here for classification. Logistic. Yes, sir.
Thank you, Dr. Kushal. And I just wanted to add one more line. And firstly, very interesting questions, everyone. And you know, this is the whole point of doing stuff like this. So we engage more and we answer as many of them as possible. And just wanted to add a line on Preeti's question on how FirstUniv course is different from other platforms which is being offered for the same course. The difference is, of course, you know, we do have some stellar partnerships. You know, we work with one of the biggest tech companies in the world, which is rendering its support for this, which is IBM. And the difference is that, you know, we are just not looking at this as a platform teaching you something and just, you know, putting our hands up after that. We are making a conscious investment in your future as well. And that includes us training you to crack some of the best companies that are out there. And we did an entire session on that, on how to get through those companies and how to apply for those jobs. So we are as invested as you are in this. So we also are guaranteeing a placement. So that's the FirstUniv guarantee, and that's what makes us different from the other players. And I think
there's a
Karan is asking
question by Karan. Okay, so should I go ahead?
Cost of function. Yes, please, Dr.
See, there are two parts. First is what is this cost function and how weights are initialized. So usually weights are initialized randomly. Okay, and another thing, the cost function tells you that how far are you from achieving your objective. For example, if you are doing regression, so generally the cost function is going to be mean square error function. Okay, and if you are doing classification, so binary cross entropy or pass cross entropy is going to be your this cost function. Okay, so you will eventually learn this thing when you will take the course or you are going to read some textbook. Okay, another thing, sir, I want to become a data scientist. How this course can help me in AI/ML? I want to course in data science. See, Ria, the thing is that if you want to become a data scientist, so at present we have huge amount of data. To analyze that data, we need the tools of machine learning. Okay, tools of deep learning. So that is going to be one more arrow in your arsenal if you want to go for data science. So at present, machine learning is like what I say, it is essential for if you want to do data science.
Right. Thank you, Dr. Kushal. And you know, as I was saying earlier, because we get a lot of questions from people from all fields of life and disciplines and how they can pivot into a career in AI and machine learning. So I think the simple answer for that would be that, you know, once you get started, you can gauge your own capabilities and your own interests, and then make an investment as to how much time you're going to devote it. You want to keep it as a part-time gig, you want to pursue this full-time, or you want to figure out a way on how you can already include this in your existing skill set. So the possibilities are limitless, and I think no one in the world actually knows the true potential of AI at the moment. We all are figuring it out, and we can help you on that journey because we've been doing this for quite some time, and we'd be very happy to extend all kinds of support possible. So I think we've got another couple of questions. Yes, please.
Yes. Which device is required to learn deep learning? See, Vikram, when you want to do deep learning, so you can do it on single CPU also, okay, but it is going to work very slow because there is going to be a lot of matrix multiplication. To do it well in a good amount of time, we need GPUs, like you know about NVIDIA. So it is going to have some GPUs like 2070, 3070 for your laptops. Okay, you can do deep learning on your laptops also. Okay, and for doing like industry scale or research level deep learning, so there are many architecture available from NVIDIA. Okay, many systems available from NVIDIA. Like if you write data science computing tower or machine learning computer tower, you will see many kinds of system. Or you can, if you don't want to purchase that, you can go online with the help of Google Colab or Amazon Web Services. So these are the ways the hardware required for deep learning is used. Okay. So Shabnam is asking, is there a future in deep learning? Yes, Shabnam, there is a lot of scope in deep learning. Okay, the amount of data humanity is producing every day, in order to make sense of that data, we need some element of deep learning. Yes. Okay, what role do I get after learning deep learning? So it all depends upon at what company you are working, what is your skill level. For example, if your skill level is very good, that you can make very good sense of data, and you can identify which architecture is going to work here very well. So initially you are going to work with you are going to start like machine learning engineer. Okay, that is going to be the first role they're going to give you if you are hired by a machine learning company. Okay, and eventually with experience you're going to grow, and it depends in what domain company works. Are they working on text processing, the natural language processing, or they are simply working on images? So depending on the skill and the requirement of the company, that amount kind of work you're going to get.
Right. Thank you, Dr. Kushal. Ankit wants to know if he can do this course. EMI, of course, Ankit, please contact our team. We have a few things that we can suggest. So we're very happy to take this conversation forward in private whenever you are comfortable in having that. So I think today there's a lot of questions, and I hope we've answered all of them. So in case anyone has any other doubts, I think there's something else that's come up. Let's check.
Okay, so there is another question for Kumar Paras. Sir, I am a student with MSc Biology. I am interested in AI and ML and have good basic understanding of Python. Is this course helpful in making my career in biotech? See, Kumar Paras, if you have good understanding of biology, so you know that there are many issues, challenges in biology, like you know about this computational biology and bioinformatics. So if you have the knowledge of tools of these artificial intelligence, like you know about machine learning, deep learning, and you know Python, and you know some libraries of Python, so you can do many things, like more related to like computation prediction. Like for example, you want to do prediction about how this drug is going to behave. So there are many models, artificial neural networks trained to do so. And if you understand these things, if you have the domain knowledge of biology and you know some artificial intelligence, by combining them, you can do cross-disciplinary research in your area. I know some people who are doing this, like they're working on protein folding and like some dynamics of molecules. Since I'm not from biology background, so I don't know much. But the thing is that it is going to be very helpful for you if you have the knowledge of like statistics and machine learning. So it is going to be very helpful for you.
That's a very good question, actually. Thank you, Kumar Paras, for asking that. Are there any other more questions? So I think we'll just wait a minute more till anyone has something to say. In case we don't hear back from anyone, I wanted to thank you all for attending today's session. This would be up on YouTube as soon as we are done processing it. And of course, if there are any other afterthoughts, please do let us know, and we will route them directly to Dr. Kushal and come back to you with an answer. And of course, our team would be in touch with you for your feedback and how we can improve these things. And we hopefully can bring you guys on board and do a more sort of a deep dive into the course and the prospect that it will bring upon completion. And until then, thank you so much. And thank you so much for joining us. Please have a great weekend, and we will be back next week again with a very interesting topic and with a very interesting speaker. So until then, thank you so much. Thank you, Dr. Kushal, and thank you everyone for joining. And we look forward to connecting with you soon. Thank you all.